Welcome to Beyond the Trade. My name is Andgel Thomas, and today we have Richard Mohammed with us, the SME for School of Electrical and Electronics. So, Richard, thank you for being here.
Thanks for having me.
All right, wonderful. So, tell me something. How did you end up in this trade? Where the story originally started from?
Well, the story started from as a small child, every young little kid with a toy, you want to take it apart and investigate to see what components it has, how you could scrap it, how you could put it back up together and get it to work again.
Yeah.
So that interested me to discovering, how all of these different electrical components, like a basic battery, a basic motor, lights, and whatever components you have in a toy, how does these things come together to make the toy work?
Mm-hmm.
And with that experience, I would have further led into different things and experimenting to discover how all of these electrical components could combine to get something to work as efficient as a toy. And that led into my career in the secondary school when I went to the senior comprehensive school. I discovered, at CSE choosing courses, the electrical course, what is really called now electrical and electronics, it would have propelled me to choosing a career in electrical and electronics. And from that, it led into different work experiences. It led into wanting to become a teacher, to share that knowledge with other persons also, and leading me today as being the subject matter expert for that school.
Oh, well, that story is an interesting one for a fact. And you are quite right. Every young child, every child I should say, they are all inquisitive. Mm-hmm. So, whether I be for welding, in your case, electrical, I don't see it possible in the air conditioning industry, but they are all inquisitive, right? Mm-hmm. So, you being the SME for electrical and electronics, right? What are some of the advantages or career paths that one may take or can take after completing a diploma here at NESC?
Well, there's many, and particularly with electrical and electronics, you could go into different directions, because we categorize electrical as being either residential, commercial, industrial.
Okay.
And with our program here at NESC, students could go in either one of the three. Primarily with the residential aspect, you would see many of the construction homes, you would see buildings that require electrical installations. So persons and students could go back out to industry, get that work experience doing residential wiring. You could also go into the oil and gas or manufacturing industry to work with motors, transformers, VFDs, some of the more technologies like PLCs, SCADA, all of the operations that you would have. But primarily with the electrical program, it has many careers that you could choose from, because what the experience you get here at NESC encompasses all of the different elements of electrical.
Okay. I know you have been with the company a while, so I know you would have been around when COVID would have struck. Mm-hmm. How did it affect the trade altogether? How did you think it affect the trade, electrical?
It affected the trade for me in a positive, it made a positive impact, because you would have seen a lot of the skilled person, they were still considered essential workers, because they were still required to go out and lend assistance where you had emergencies for homeowners, you had emergencies in industry also. So the persons in the electrical field, it would have impacted them positively because they were still able to go out and work. There was some negative impacts also because of that, because some persons would have lost jobs. When you look at the training environment, it was very difficult now to teach TVET programs like electrical, welding, refrigeration using the online platform, because we couldn't have students in the campus. But for the trade itself, it was somewhat of a double-edged sword, where some persons could have gained employment or continued to work, and some persons lost their job.
I heard you mention VFD, right? So that's a efficiency technology on its own. Mm-hmm. So what other advancements or improvements would you say that currently situated in the trade?
Other than VFDs, VFDs primarily, we look at electronic part of the field and the trade, and VFDs encompass a lot of the newer technologies like transistors, different elements such as renewable energies also use the essential operation of a VFD to implement in inverters. Mm-hmm. So you would have seen the technology move from the 1980s into the 1990s up to now, where VFDs would have transcended using the technology of a VFD to use in renewable energy systems.
Oh, makes sense. Yeah. My question. So you seem, or I shouldn't say you seem, but you know a lot in the industry. Mm-hmm. So would you say that being in the industry is demanding, when I be physically or mentally, or both? How do you see it?
One, I would say, when you look at the mental impact of it, persons who work in trade and who work in the TPET environment, they need to be cognitively ready. Because when you look and you see the level of troubleshooting and repairs you need to do with some components, when you look at the level of the cognitive focus of repairing something, it takes you more time to figure out what is the problem than to actually fix it. So for me, you need to be ready to apply that knowledge when you go out and you experience and see different problems and how you're going to solve them.
So you mentioned solving problems, troubleshooting stuff. So what are some of the core skills someone who's interested in the program, okay, they graduate? What are the core skills they could anticipate to acquire after finishing the program?
Yeah, so core skills you could acquire after finishing the program. One, it would be the ability to go out to industry, it would be to assess problems and repair. So just as in the electrical field, you might go out to a residential home and someone would say, well, my water pump is not working, and the electrical person may not be quite familiar of plumbing and installation of the pump and whatnot. But with the application of the skills that they learn from the program, particularly in the year 2 part, they would be able to troubleshoot and assess, okay, this is the symptom that I'm getting from the pump not being able to work properly. These are some of the possible repairs, these are some of the possible causes, process of elimination, and they could narrow down what could be causing this issue. Probably the pump might need to change a capacitor. Sometimes the motor end of the pump might need to change. Sometimes the pump end might need to change. So a person coming out of this program could go out and apply that knowledge and solve problems. And as a sideline too, they not only could do electrical work, they could also do some aspect of mechanical too.
As well?
Yeah.
Okay, well, it's a win-win for everyone.
Yeah.
Right? So tell me something. What advice... Okay, before I ask that question, most people think electrical, they're afraid to get shock, number one.
Definitely.
But working with circuits, you can't play mass and afraid powder, as you would say it. So what are some of the key things you want to bear in mind when working with a live circuit? What are some of the dangers, some of the precautions you want to take?
Well, I'll start with some of the precautions. One of the things that you need to be inherently cognizant about is what level of voltage you're working with. Many times you go out and you hear people talk about 110 and 220. One of the things that you need to anticipate when you work with electricity is you never know what is the value of voltage you're currently dealing with. So the key component that you would have and need to be equipped with is a test instrument. So as a person working on these things, you need to be able to know how to use that test instrument to verify what value of electrical potential you're dealing with, and also what preventative measures and precautions you need to take when working on live circuits. Because not every person could go and stick their hand into a receptacle outlet or a panel and decide, well, I know what I'm doing. For me, I use the rule that your meter should be your first reference point to verifying what you're dealing with. Because you never know what you're going to encounter, and you should always know, okay, I'm dealing with something that is 120 volts or 240 volts or something larger. And that with thinking and measuring those values, you would know how you're going to go forward treating with it.
So tell me, what advice would you give, for example, me? I'm a regular homeowner, right? Or I'm a business person, and well, the lights in the office or in my building is down. What advice would you give me? Okay, I know how to use a meter, I watch a YouTube video, but still, how to guide me? Give me some advice before I go in and open that panel. What should I look out for?
Well,
what should I expect?
Well, first thing, so your example there is the light's not working.
Right.
The first thing you should check to see is to verify if the lights have power connected to it.
Okay.
And you might want to just go and make visual observations. Well, okay, a visual observation might be to identify if the light needs to be replaced. The lighting fixture may need to have a lighting outlet or a bulb change. And then you could verify, if there's sufficient power, if there's available power in the lighting fixture. So as a homeowner, many times you see homeowners, okay, your light not working, let's change the bulb. That's the first
instinct,
port of call. And that's the first instinct you would go to, and the first thing you would try to change. But as a homeowner, you need to recognize that there may be particular things that you need to check before you go and do that. You might want to go and open a distribution panel and observe if there's anything off. Sometimes it may have tripped for some reason, or someone may have intentionally turned it off. So those are things you want to look at as a homeowner. You want to observe as you go along. You want to check before you actually go and do something that you're not too quite clear about.
You mentioned trip. So that's general knowledge. What exactly would be the cause of a breaker tripping?
Well, primarily a breaker is designed to carry or distribute a certain amount of current. So typically in a home you might have a 15 amp circuit breaker or a 20 amp circuit breaker. So the breaker is designed to distribute a particular amount of current at a particular voltage. So that circuit breaker, what could cause it to trip? One, it may be that someone turned it off.
Right.
That wouldn't be tripped. But if it did trip, it may be that it's carrying too much current above its design limitation.
If it's designed for 50, and let's say, for example, it's had to pull 20 amps, it would trip the breaker.
It would trip definitely.
Okay, all right. Makes sense. Okay.
And then also you may have particular situations. For example, we were mentioning about lighting outlets. You may have a ground fault. And some people, a lot of times you see people say, well, when you connect a circuit, you don't know about you don't really need to connect a grounding conductor. Your grounding conductor is very important because not only does it provide a separate path for fault current to flow, it also provides the ability for circuit protected devices to operate. So many times you hear people say, well, ground not necessary.
Yeah.
We could cut that out and we could leave that off. But it is crucial because if grounding conductors are not terminated properly, circuit protective devices may or may not, in most cases it may not operate. Yeah. And I've experienced that many times with homeowners.
Oh, wow. All right, so you have a small trivia, nothing too difficult, simple, straightforward. So we have a small trivia here, right? So first question, what is the first step in troubleshooting an electrical circuit?
So first step in troubleshooting an electrical circuit would be, one, verify if you have available power at the receptacle outlet. So typically with the average Joe, you might plug something in and you might, it's not working and you might think it's the device itself, like a vacuum cleaner. So before you decide that, okay, it's not the vacuum cleaner, you would want to check, okay, if I have available voltage or if available power at the point of utilization, you might want to plug something else in. Process of elimination, of course, and if you verify that, okay, the other device that I plugged in is not working, you may want to go and check your distribution panel to see if there's anything off.
Or breaker trip.
All
right, cool.
Yeah. If you reach that point where you verify that, okay, this is not working, you may want to call someone who is professional, because when you deal with electrical circuits and you're not too clear of how to handle that or how to treat with a situation like that, you need to always refer to someone who's a professional.
Yeah.
Not everyone can play hero and go and deal with an electrical circuit because it's not something that you see. And if you do see, if you can say that you could see electrical, then that might be the last thing that you actually see.
Yeah. All right, cool. The second question, what tool is commonly used in measuring electrical voltage, current, and resistance?
Well,
one tool.
As of now, the one tool would be a very cheap but reliable multimeter.
Okay.
Now on the market, you could get multimeters ranging from $200 up to $5,000. But for me personally, once it could give you a numerical value,
yeah,
it's a meter that you would need.
Okay, cool. Yeah, that's good. Number 3, why is teamwork important in electrical installation?
So electrical installation, I'll give you a real life example. When you're doing electrical piping and cabling in a home, it's not a one-man job. Especially when you're looking at pulling conductors, installing cables, installing outlets, it's not a one-man job. You need to have clear communication with that other person, because that other person is the one who would need to give you assistance when you need assistance. So many times you would see tradesmen going out and they say, well, I like to work by myself. But it's not always like that, and you would experience it firsthand. When you try to do things on your own and you're stuck in a jam, as they say, you need someone there to help you. So teamwork is very important, and not only teamwork, being able to communicate with that person you're working with on your team clearly.
Yeah.
Because that person might be the person to save your
life. Yeah.
Especially with electrical. There's a lot of electrical standards, a lot of electrical safety requirements that the industry mandates that you need to conform with. And the person that you work with in a team, and it may be more than one person, those are the persons that would have your back at the end of the day. When you deal with larger installations, especially when you're dealing with live circuits, as a matter of fact, you would want that person having your back. In the event that you come into contact with a live energized conductor, that might be the only person that is there to recognize that this person is in some sort of problem, and that would be the person to save your life.
Yeah, I certainly agree on that point. So, what color is typically used for ground wires in an electrical circuit?
Well, different countries have different codes, different standards, but for Trinidad and Tobago primarily, we have one of the I would say, from my experience, one of the best standards for electrical codes and requirements, and green or green-yellow.
Okay, perfect, spot on. So what is the unit of measurement for electrical power?
Electrical power, what if I told you I don't know? Well, electrical power is measured in watts, kilowatts, megawatts.
Okay, cool.
In some cases, gigawatts for larger distribution systems.
All right, cool. Well, thanks so much for being here, Mr. Mohammed.
Thank you.